Welcome, viewers. My name is Steven, and this is Safe Space. If you made it here by mistake, this is a presentation for the Portland State Computer Science 2020 Capstone project, where students take on real-world development challenges and work in teams to tackle a problem presented to them by a local business or sponsor. Due to the current ongoing COVID-19 crisis, we were sponsored by the professor for this course to develop an idea and solution to help people through the tough situation we are all in. What we decided on and have produced is a lifestyle application for Android that provides daily challenges, local heat maps of cases, and gentle reminders to maintain social distancing protocols. We were inspired to help people mentally and physically by motivating people to self-improve, stay positive, and keep their safe space. Let me show you our project. This is the home screen for our application. Here you'll find your challenges as well as how many lives you have remaining for the week. Don't like the color scheme or the life type? Simply change them in our settings screen. Here you can change the theme and the life. Also, you can log out or delete your account from this page. To learn more about a challenge, simply click on it, and it'll give you a description or ways to complete it. Don't like a challenge? Simply refresh it by clicking here. That's something I can do. If you complete a challenge, you can mark it completed from this page as well. Marking a challenge complete will gain your account experience points, which can be seen on the profile screen. Here you'll see your total score as well as weekly streak, which is calculated by how many weeks in a row you've been able to maintain social distancing. Finally, we have our heat map. Currently, we only support the greater metro area of Portland, but hopefully we can expand this map. This map is color-coded by zip code to show how many cases have been reported in each area. Clicking on a zip code will show you how many cases have been reported there. Wow, better avoid that area. Also, if you want to learn more about an application, simply hit the eye in the top left corner to get some helpful tutorials about how to use it. Next, I'm going to pass it off to Stefan, who will explain some of our features that are included in our application.
Thanks for the demo, Stephen. To clear up any confusion, I am Stefan Berezhnoy, and I'm going to go into a little more detail about our app's features, starting with the major features involving challenges, the COVID heat map, and hit points. First, every user always has 3 challenges active. If you don't like a challenge, you can refresh it to get a new one. When you complete a challenge, you earn the score and levels associated with that challenge, and you get a new challenge immediately added back to your active challenge list. There are 3 types of challenges: physical, mental, and social. Physical challenges might involve running a mile or doing 10 push-ups. Mental challenges would include reading a book or making art. And social challenges would have you text a friend or call your family. Some physical challenges include a video to show you the correct form for the exercise you're being asked to do. Within each challenge type, there are 3 difficulties: easy, medium, and hard. An easy physical challenge might be doing 10 push-ups, where a hard one would be to do 50. An easy mental challenge would involve reading the first chapter of a book, where a hard one would be to finish the whole book. And an easy social challenge would have you text a friend, where a hard one might be to call your parents and have a conversation. With this variety of challenges, and with the ability to refresh to get the challenges you want, we believe that anyone who picks up our app can find something healthy and productive to do. The COVID-19 heat map shows confirmed COVID case data by zip code. Green-colored areas represent 0 cases, and red means there's a high case count. You can tap on an individual zip code to get the actual case count. The social distance hit point system uses low energy Bluetooth to determine if you're too close to someone by using the strength of their Bluetooth signal. If you get too close, you'll lose a hit point. You get 3 hit points per week, and you receive back up to 3 at the end of the week. If you survive the whole week with at least 1 hit point remaining, You'll get a weekly streak going, which increases or multiplies your score from challenges. If you lose all 3 hit points, you'll have to start over with your weekly streak at 0. Finally, to wrap up, I'll mention the profile and settings screens. The profile screen gets information from your Google login to get your name and picture. It also shows your current level, your total score, and your weekly streak. The settings screen allows you to change the app's aesthetics and log out or fully delete your account data from our backend. Now, for a discussion of the development and design process of SafeSpace, I'd like to pass it off to Tenzing Rither.
Hello, I'm Tenzing Rither, and now I'm going to talk about our dev process for the entire project. We began the project with an initial research with brainstorming design ideas together and looking for helpful tools to use for our app. Then we jumped into the design phase of our app, which included an initial prototype, and the front-end team was able to come up with a wireframe using Figma as their tool. Then we moved on to creating a requirements document listing the technical and non-technical requirements for our app. This doc was there for us to refer back to later on during the next phase, which was implementation. This was the longest phase of our dev process and included the entire team working together developing code based on the issues assigned to them. The project was managed through GitHub using GitHub issues. We made sure not to overlap issues, so everyone was working on a separate component or screen of the app. We had weekly stand-ups via Zoom or Slack and weekly one-on-ones too. Team meetings were twice a week for the majority of the time, and front-end and back-end teams had their own working sessions together as well to pair program. Finally, we move on to the last phase of revise and deploy. During this phase, we conducted minimal testing and revising of the app and then uploaded our app as an APK to our repo, which is available there for install. Moving on to team roles, as you can see, everyone on our team was an SE or software engineer. Alex was the front end lead and I was the team lead. We had 2 teams including the front end and back end. Kristopher and I were working on the back end, and Stefan, Stephen, and Alex were working on the front end. Now we're going to discuss who did what for the app. Beginning with Alex, he worked on the Bluetooth feature of our app, ejecting our Expo project to Android, setting up the heat map feature, and creating tutorial screens for users. And just want to give a shout out to Alex here for really getting the project rolling with a prototype early on and tackling some of our more difficult issues for the app, like Bluetooth and exporting the app to Android. Stephen worked on the settings screen, themes for the app, providing options for different health icons, the logo for our app, profile screen, setting up the logic for users to upgrade a level by score value, and getting async storage up on our app for saving data to local storage. Stefan worked on the challenges screen for users to see their challenges, and he also worked on video embedding for challenges that included a video to be shown. Kristopher worked on authentication for users signing in with Google and the home address page along with Stephen as well. I worked on the database and getting the functionality on the back end to work, and then getting that hooked up to the front end so the user would get the right data back to them.
Hello, my name is Alex Springer, and I'll be talking about the front-end architecture of SafeSpace. To build the front end of SafeSpace, we wrote our project in JavaScript, we used React Native as our front-end framework, and used Expo as our workflow for the project. To further elaborate, React is a JavaScript library for building user interfaces. React Native combines the React library with native mobile development to build applications that work on both iOS and Android in the same codebase. Especially for individuals with some web development like myself, React Native was the perfect way to get immersed into mobile development. Typically, mobile apps are either written in Java for Android or Swift for iOS. As mentioned before, React is a JavaScript framework. Thus, React Native takes JavaScript code and renders it into native platform UI. This means React apps use the same native platform APIs that other mobile apps. One of the major benefits of using React Native is the easy accessibility to many helpful libraries. 3 standout libraries for developing SafeSpace were React Native Maps, which we used to build our heat map of COVID-19 cases by zip code in the Portland metro area, React Native BLE from Palladia, which is the Bluetooth Low Energy library we use to allow communication between devices in order to enforce the social distancing rules in SafeSpace, and React Native WebView, which allowed us to embed videos into our challenge screen. While React Native provides a layer of abstraction from pure native code, Expo goes a step further. In fact, while using the managed workflow Expo provides, our team never had to directly touch native code. Additionally, while in the managed workflow, we didn't have to use tools such as Android Studio or even Xcode. We could just write JavaScript code and allow Expo to take care of a lot of the complexity in creating mobile apps. But what is Expo specifically? Expo is an open source toolchain built around React Native to help developers build native iOS and Android applications using JavaScript and React. Expo makes developing mobile apps really simple. For example, the Expo command line interface has a command to bootstrap your project and give you a simple starting point. Additionally, running and testing our app was as easy as downloading the Expo client from either the App Store or Google Play, and then using the camera on our phones and tablets to scan a QR code to download and build the JavaScript bundle. If we could have worked in Expo's managed workflow for the entire project, we would have. But unfortunately, Expo doesn't support all native APIs. For example, Expo doesn't have a built-in Bluetooth API, so to get Bluetooth functionality in SafeSpace, we had to eject our project from Expo's standard managed workflow into a bare workflow. In a bare workflow, Expo tools and services are more limited, and as developers, we are now in full control over every aspect of the native project. While complete freedom seems nice, by ejecting we relinquished our ability to run the app on our devices by simply scanning a QR code. Additionally, our team had to set up environments on our respective computers to now support Android Studio and the prerequisites needed to physically download the application onto our devices. However, this step would have inevitably been taken because to publish an app to the Google Play Store, it needs to be ejected from the managed workflow anyway. To recap, the user interface for SafeSpace was written in JavaScript, with React Native as the framework and Expo as the workflow. We began with the managed workflow and eventually transitioned to the bare workflow as we needed more control over particular aspects of the native code. Now Chris will detail the backend architecture of our project.
Hello, my name is Kristopher Kinzler, and I'm going to be covering the backend architecture that we use to create the React Native app. We decided to hook the app up to Google's Firebase, which is a platform in the Google Cloud, which makes it easy for developers to include different services into their apps. Firebase makes it very easy to connect your app up with a database. So for our app, we decided to use Firebase's Firestore database, which you can just make calls from in the app itself to set information or get information that you need. Setting up the schemas is very straightforward with the Firebase console GUI. Right here I just have highlighted a collection that we created for user profiles, and then each document is created for every user, and they have specific fields like active challenges, challenges that they've already completed, an email, and a lot of this information we set ourselves, but also some of the information we can get when we authorize the users when they sign in with a Google account. So for authenticating users, we went ahead and just used Google authentication, which means you just have to input their email and their password for Google, and then they'd be authenticated. As you can see, there's many different options that you can enable in the Firebase console if you wanted to authenticate with Facebook or Twitter or even just an email or password. But we went ahead and did it with Google, and with the UID, the authorization UID that's returned in Firebase, we use that to set up that user's specific document name so that we could reference it and get their profile information as they complete challenges and as they need new challenges while they're using the app. We also decided to use some of the APIs that are available in Firebase in the Google Cloud. So for one, we used Maps SDK for Android. Alex used that in order to create the heat map, and we also used the Places API so that when there's a new user who logs into logs an account, they immediately go to a screen which allows them to put their home address in, and Google Places API, you can get more detailed information off of their address, which is auto-completed to make it easier for the user. And then we can grab from that a latitude and a longitude. And that was then sent off to another function inside of the application which sets their home address and circumference around that, which tells the application to turn off Bluetooth so they wouldn't be losing any hearts while they're in that safe space. And because that information, the latitude and the longitude, is persistent, you probably aren't going to be moving your moving houses too often. We decided to use asynchronous storage instead of making calls to and from the database to get that information. So Stephen was able to set up an asynchronous storage on the app itself so that it's persistent, and whenever the app is opened up, we would know exactly where the user's house actually was. So for this slide, it's pretty straightforward. I just wanted to show the call that was used in order to get information or set information on the Firebase database. Since it's in the cloud, all the schemas that you created are made through that Firebase console, and all you really need to do is grab the data that you want to send or know the information that you want to get back from the database and just make a call, which made it very simple for developing. And then on this final slide, I just have asynchronous storage call inside of the React Native app, which is used to set the latitude and the longitude and can be passed around through different screens and different functions throughout the application. That's it for the backend architecture. Now I'm going to hand it off to Alex, who's going to go over some of the hiccups that we came across along the way while we developed this app. Thank you so much.
Hello once again, I'm Alex Springer, and I will now be presenting some surprises we encountered during development, as well as client feedback for the app. While developing SafeSpace, the team encountered many different surprises. One surprise I touched upon while discussing the front-end architecture of our project was ejecting out of the Manage Expo workflow. For someone who has experience with this project, it wouldn't have taken them more than an hour to set everything up from scratch. Fortunately, I did not have prior experience with this procedure, so I dumped countless hours into troubleshooting this process. It was one of those situations where, regardless of how much time you spend on the issue, there didn't seem to be a guarantee that a solution would be found. After scouring through loads of misinformation on various forums and websites with no success, I eventually found the solution. It turns out when the command asks you what you would like your package to be called, you don't actually have a choice. After fixing this simple naming issue, the Android project is successfully built and installed to my device. An annoying problem with an equally annoying solution. Another surprise arose when implementing the Bluetooth social distancing functionality in SafeSpace. Originally, the team wanted to allow users to whitelist certain devices so they would not be penalized for coming too close to other devices they own or devices owned by people they live with. Interestingly enough, in the library we use for Bluetooth, device ID for other devices would change every time the application was run. This made it virtually impossible for the team to add whitelisted devices. Instead, we chose to just turn off Bluetooth scanning while individuals are at their home location. While this is not a perfect fix, for example, there may be false positives if you're riding in a car with someone you live with, these would not be fixed without a fundamental rework of how Bluetooth is implemented in our app. Now I'd like to transition to client feedback. While developing SafeSpace, our team didn't have a specific client. Rather, the purpose of the project was to help people stay happy and healthy during the stress of a global pandemic. While most testing and usage of the app has been within the development team, client feedback has been overwhelmingly positive. When asked about our app, one user stated, "I'm super excited about the SafeSpace app. It's easy to use and immediately compelling. During a stressful crisis like COVID-19, it's important to promote mental and physical health elegantly without any learning curve." The SafeSpace team is extremely happy and proud of what we've been able to accomplish. We'd be very grateful if you would check out our app. Currently, the APK is available on our GitHub repository for Android users. Now I'll hand it over to Stephen to close out our presentation.
Thanks, team, and thank you, viewer, for watching. If you are interested in our application, check out our Git repo at this link, also posted in the description below. If you have ideas or feedback, leave a comment, and if you know someone who might be interested in our application, send them our way. Remember, we're all in this together, so stay healthy and keep your safe space. Thank you.